single-page apps architecture. I know it's after lunch, and there's not going to be a lot of code in this one like my other sessions, but what we want to talk about in this session is understanding the way that building web applications is evolving in today's world. So we want to get an idea of what some of the architectural, kind of the high-level and mid-level differences are in terms of building modern web applications. Okay? That's going to be our general theme for this session. And what we're going to do is we're going to talk about client-side JavaScript, single-page apps, obviously, architecture, and I'll give you some useful resources to help you understand where we're going in the single-page apps world. Well, before we get started, I just want to take a quick survey and see what different things people are using. How many people are using Angular today? All right, so that's a fair number. Anyone still using Backbone? Okay, a few people. So what other JavaScript frameworks are you guys using aside from those two? Just shout it out. Did someone say Jquery? That's not a framework. No, I'm just kidding. It kind of is like a framework. It's more a library. Someone said Dojo. What else? Knockout. Okay. Interesting. I didn't realize Knockout came all the way over here. What's that? What else? That's not a framework. That's just a utility. Someone said Require.js. What else? What's that? Ember. Oh, wow. Okay. That's interesting. You don't hear a lot of people using Ember in the Java community. Ember is very popular in the Rails community because the folks who created Ember.js were essentially Rails guys, right? Yoda Katz is one of the lead organizers. But we'll talk more about those frameworks in a few minutes, but we want to understand the architecture behind the different types of frameworks that are available. Maybe look at how they do things in a slightly different way. But the main thing that we need to understand in this session is that the world is changing in terms of how we look at web applications today, right? And there's some subtle things that we want to understand. So I want to introduce some terminology first. So the moniker single-page apps is something that's relatively new, but there was an idea called SOFEA, or Service-Oriented Front-End Architecture, that's been around for a while, actually. I think the term was coined back in 2006, so obviously it's 7 to 8 years old now. But they basically mean the same thing, right? But I actually prefer the term SOFEA because it gives you an idea of what you're actually aiming towards, right? When you say single-page web application, it's kind of very vague. But when you say service-oriented front-end architecture, it has some meaning to it, right? Essentially what you're doing is that you're building front-end architecture or a front-end app that relies on a service-oriented model. And that's what we're going to explore in this session, right? And for those who are completely new to single-page applications or to SOFEA-based applications, what the major difference is that single-page applications don't send a brand new HTML page for each request or each user interaction. Essentially, once the single-page app is loaded in the browser, the entire page is never refreshed, right? Everything happens via AJAX and other types of interactions. And the other big thing is that we're moving a lot of the business logic that we traditionally have in the server up into the client, right? And that's a very specific type of logic. It's user interface business logic, not necessarily a database call or some kind of algorithm you run. Okay? But we're moving that stuff up to the client, i.e. the web browser. And essentially what the single-page app does is, as it's not refreshing the entire page or reloading a page or pulling in a brand new page when you click on something, what we're doing is we're communicating with the server using an AJAX call to grab data, right? So I've been writing web apps for a long time, actually. I wrote my first web application using C back in 1995. So I go way back. And then after that got, writing C-based web applications using CGI bin, right? Does anyone remember CGI bin? Right, so we have a few old schoolers in here, right? So, you would build a web application using CGI bin, write it in C, and it was a very long, kind of arduous thing. And then a lot of folks in the community started using Perl for a while. And so I was like, all right, let's use Perl. It seems like it's a little bit better way to write web applications. And after building a few web apps using Perl, I had to go to therapy for about 3 months, right? But anyways, that's a Perl joke for those who know Perl. It's not a very friendly language. But the point is back in the early days of the web, the way that we built applications was we would literally generate HTML on the server. We would say HTML tag, div, li, etc. We would build out the HTML. Obviously using the machine, using an application, but we were essentially just generating a large string that represented an HTML page. Okay? So if you think to what do you do today, though, most people are still building web applications like this. If you're using something like Grails, or if you're using Spring Web or whatever it may be, you probably are still doing a lot of HTML building on the server. Okay? And so that's why in this slide I say we're still generating HTML like it's 19 Google put out called Google Maps. So I went to map.google.com, and my immediate reaction after playing with it for about a minute was, holy shit, you can build this in a web browser? If you guys remember when it first came out, it was probably the most sophisticated application. You could zoom in and had little markers, and it's like, wow, you can build stuff like this. I had no idea. So for me, at least, that's when the light bulb went off that you could build these rich applications in the browser. But that was back in 2005 or 2006. So it took us a little while as a community to get to a point where all of us could build stuff like this, And a lot of it has to do with the fact that we have lots of great JavaScript libraries now that help us do it. So we don't have to work way down at the low level and write kind of really bare bones HTML, JavaScript, and other things like that. And the other thing that really made this possible in terms of building rich applications in a browser was that we have much better browsers today, and we have great JavaScript engines. So it's no longer slow running JavaScript on the browser. Most browsers, especially if it's a modern browser like Chrome or Firefox, they have excellent JavaScript engines. And those JavaScript engines, in terms of performance, rival the JVM, okay, in just raw performance. Right? And that's made a huge difference. One thing I should note is that we're not going to be talking about generated front-end applications like GWT. Has anyone used GWT or used it before? Right, so you guys are familiar with what GWT is. Essentially, you write Java code, and it spits out all this JavaScript that can then run on the server. Basically, you code everything in Java. We're not talking about things like that. We're actually talking about writing JavaScript. Okay? So part of the problem, though, over the last few years is that there's been a massive amount of frameworks that have come. At the beginning, I asked, hey, what are people using? And there were literally a dozen different answers. Right? And this is a good thing in a way. Right? Choice is always good. But part of the problem with that is that there's not something that people can point to and say, yes, that's the way we build apps now, right? Having all those different frameworks, it balkanizes the way our community is put together, the JavaScript community at least, right? There are tons and tons of different frameworks. There's way more than that are listed here. But a problem that a lot of people have is, how do you choose a framework? Which one should I use, right? And people ask me this question all the time. And my answer to that is, I have no idea what framework you should be using because I'm not building your application. I know nothing about your app, right? And a lot of times, the framework that you choose has a lot to do with the skill set of you and your team. It has to do with what kind of application you're building and what your business goals are, right? And we know what the dangers of picking one of these frameworks is. There are actually several dangers in using something like Angular or Ember or Knockout or whatever it may be, right? We'll talk more about that in a bit. But why do we need to use these frameworks? The problem is that at its core level, JavaScript, unfortunately, does not have a lot of the language constructs, platform constructs that we need to be able to build large code bases, and code bases which are maintainable and testable and other things like that. So what happens is if you don't use a framework, you eventually end up with a big mess. Sorry, not eventually. You very quickly end up with a big mess. Okay? So you end up writing a lot of boilerplate code. Reusability is an issue. And you could invent all that yourself, but why invent it when other people have come together and built a nice framework that you can use, right? So that's why we want to use frameworks. But there are lots of low-level things that we can use as well that can help you along the way, without jumping all the way into a framework. You can use something like Underscore or Sugar.js, which are lower-level utilities, but give you those mid-level constructs that help you build a larger code base. All right, so let's talk a bit more about SPA and SOFEA. We've covered, using JavaScript. How how we can, what are the different things that we should look for when we want to use JavaScript frameworks. But when we talk about client-side single-page web applications, essentially what we're talking about is moving UI business logic from the server up onto the client. And this is a huge shift in terms of the way we need to think about building a web application. We're essentially moving some processing from the server up to the client. And in a lot of ways, the way we want to think about it is the server just becomes a RESTful endpoint. It doesn't actually hand us HTML that we can render on the browser. What we do is we make an AJAX call to go get a list of items. We make another AJAX call to say the users pick these items and want to put them into a shopping cart, right? So we make all these different changes. We think in a different way. Instead of having a submit button that does a pull request and then gives us a new page, what we want to do is we want to just send a little AJAX call and say, hey, the users pick these items, and then do an in-situ replacement of the DOM, i.e. update the user interface in situ without doing an entire page refresh. Okay? And obviously the caveat with this is, yes, I'm talking about moving business logic from the server up to the client, but of course you will have business logic still on the server. But it's different kind of business logic. All right. So what are some of the reasons to build single-page applications? There are lots of good reasons. Some fundamental reasons are you want to decouple the UI and data as much as possible, right? Again, the web browser is the user interface. It just goes and grabs data from the server, right? It's not going to go grab UI elements that you then render into the HTML browser. And you want to try to avoid doing the HTML generation on the server as much as possible. So, especially for those folks that don't do a lot of JavaScript, you may think, wow, writing all that JavaScript is going to be painful, right? And actually it is painful compared to writing just Java code. And the reason for that is because as Java or Ruby or Grails or whatever developers, we're used to a specific motif. We're used to having these great tools. We're used to having all the best practices and patterns, right? We've been doing this for years, so we understand that. And the initial reaction that I get from some people is like, wow, we're really going to write a ton of, instead of writing Java code, we're going to write all this JavaScript code. That sounds like a really bad idea, right? And the good news is that as a community, we have a much better understanding of how to write large JavaScript code bases today. We have books and tutorials and other things today that we didn't have 5 years ago. Like there's several good books on JavaScript design patterns, for example, right? And I've listed some of the patterns that are popular when building JavaScript applications, but you get the idea. We didn't have these things. When I started doing a lot of JavaScript work 3-4 years ago, we didn't have the JavaScript design patterns book by Adi Osman. We didn't have object-oriented JavaScript. I think that's by Stefan Stoyanov, right? We didn't have these books out there and these other things, and just in general, understanding in the community on how to write engineering, how to engineer JavaScript instead of just hacking JavaScript, right? So this is the book I mentioned just a second ago, JavaScript Design Patterns. You don't actually have to buy this book. You can just go to the author's website, and he has the entire contents of the book on his website. Actually, it's on his GitHub account, but he has a link to it off of his website. This is an excellent book. It's a little bit dense, but it's at least minimally worth skimming through to understand how all these different design patterns that you are already aware of from the Java world manifest and are implemented in JavaScript. So in a lot of ways, as a developer, you have to ask yourself, are you ready to go all in and do client-side JavaScript, to build single-page apps, and understand what the changes in the architecture is? So you have to make a little bit of a mental shift when you do this. Sorry, it's quite warm up here on stage. Now, I will caution you that single-page applications are not for every type of app. They do have drawbacks. And there are cases, a lot of cases actually, where you don't want to build a single-page application. If you go to this link, there's a nice postmortem that this person did on building a single-page app using Backbone. It's a couple years old now, but that's okay. Well, a year old now. But that's okay. He has some great points in there where he talks about the various reasons why they built a single-page application, and essentially they backtracked from that and are using more of a standard traditional web application style. Okay? And some of those drawbacks are on this slide. One of the biggest things is that if you're going to use a framework, which you pretty much have to unless you want to write your own framework, right? And that can be fun to write your own framework, but you probably have other things to do with your time, like, I don't know, implement your business solutions. One of the problems with using any framework is that you get locked into that framework. That means if you're using Angular, do you think it's possible to port that to, I don't know, say, Kendo Ui, Sencha, or EXT? How easy would it be to do that? I don't know, take a guess. Say you spent 3 months, 3 man months building an app in Angular. How long would it take you to port that Angular app to, I don't know, let's say Sencha Touch? Right. It basically takes you, they said 2 months. It basically, the rule is that if it took you 3 months to build something in Angular, it will probably take you 3 months to build it in another framework, right? Because you also have to learn that framework along the way and whatever. But anyways, the point is that none of your code is really reusable. You can make it reusable, but again, you don't get portability between frameworks. You're basically tied to the style that the framework dictates on you. The other problem with single-page apps is that they can actually be slower. Right? If you're doing a lot of processing, if you're doing a lot of JavaScript and DOM manipulation, and especially the DOM manipulation part on the client, it can be slower, right? Because there's one thing that web browsers are very, very good at for sure, and that is rendering HTML. If you give a web browser a big block of HTML, CSS, it will be able to render it very quickly because that's what web browsers are tuned to do. But doing DOM manipulation, doing in-place changing of the DOM is actually quite slow as opposed to doing a full-page render, okay? And the third bullet point on this slide is search engine optimization, or SEO. How many people care about SEO for the stuff they build? Right, so there are a few people. So I suspect the other folks in here probably are building enterprise apps where you don't really care that much about SEO, right, or search engine optimization. Care about SEO, though, you have to be very cautious when picking and building with a framework. The ability to do SEO, but you have to make sure that you follow some rules and write your application in a certain way so that it can be properly spidered by a search engine like Google or Bing, okay, or even an internal search engine. And the other problem is, actually, whenever you give any talk on the web, you have to have a slide on IE as a problem, right, Internet Explorer. So, you have to ask yourself, well, if we build a single-page application and we use Angular, or we use something more sophisticated like Ember, which is more finely tuned for WebKit-based browser engines, is this app still going to work on IE? Okay? So how many folks still have to support IE6 for their applications? Do we have any lucky people here? Oh, right here. Okay, in front. Right, so how old is IE6? I think it came out in 1984, right? Sorry, 2004. Right? It came out a long time ago, almost a decade ago. Is that right? When did IE6 come out? Was it 2002? Right. So there you go, even more than a decade ago. So if you have to support older versions of IE especially, it can be a problem. The newer versions of Internet Explorer are actually pretty good. But again, a lot of it depends, especially if you work in the enterprise. Your user doesn't get to pick what web browser they run your stuff on. It's, you have to run it on IE, right? Sometimes, depending on your enterprise. So the good news is that at least if you're able to sidestep the old browser issue, modern browsers have excellent JavaScript engines, right? I already talked about Chrome and Firefox. They have, for example, Chrome has V8, which is probably the fastest JavaScript engine around. But there's a little bit of competition between the folks who make Chrome, IE, and Firefox, for example. What they do is all three of those groups are working on beating each other in terms of JavaScript performance. And that has really pushed the performance of these JavaScript engines forward. Right? There's always having some competition between people trying to make the same product is good for everybody because it pushes people further and further to build a better product. Right? Let's talk about the view layer for a few minutes. So this is a nice diagram. The URL is here on this page if you want to pull it up. This is kind of like the entire spectrum of where we've been and where we're going. So if we start on the far left, we have server side. Right? This is what I talked about, traditional web applications, where you generate stuff on the server. You generate HTML, you pump it up to the browser, and the browser is essentially a rendering engine for your HTML, and nothing more really. Okay? And what we do is, let me make sure I'm on the right slide here. Right, okay. So, and what we do in traditional web applications is we may use some kind of templating, like, God forbid, JSP. Is anyone still using JSPs, by the way? Oh my God, you're kidding me. Wow. 2004 call, they want their JSPs back. Okay? But that's okay. I understand that sometimes you have to work in a constrained environment. But when you're building JSPs, you know, you have markup, and inside that markup you may have a database, some kind of decorator around an underlying database, and you essentially inject data into some kind of template, right? It's a basic server-side templating kind of thing. And we use JavaScript and these kinds of things to maybe do filtering of a list or ordering a table or something like that, all right? So the next thing, kind of the next evolution, was what's known as Pjax, right? So we're moving from left to right here. So we talked about just doing direct HTML manipulation. Now we want to talk about Pjax a little bit. Pjax is what is known as push state and Ajax. So what you do is, or what we do in this case is, we have a little bit of JavaScript that just goes and updates a small part of the page. A perfect example of this is having a login button. The user puts in their username and password, and instead of refreshing the whole page, you swap out that login form for a welcome back to Amazon, Pratik, or whatever, right? So you don't refresh the whole page. You basically just do a small replacement using JavaScript of that specific part of the page, right? So as we move from left to right, we're starting to go into the modern era here. We want to talk about markup-driven views and model back views. So, So now we have widget frameworks, which are basically all JavaScript. What we get is we get UI widgets provided by a framework, and some examples are Ember, Enyo, Sencha, Kendo Ui. There's a bunch of them. And essentially what you do is you don't really code that much in HTML and CSS anymore. You still have some CSS, but the idea is that you write JavaScript code that instantiates a component, and that component or widget is something that you then attach, again, programmatically in JavaScript to some kind of virtual view, and the framework takes care of putting that actually in markup and inserting it into the DOM. Okay? So that's essentially what we call widget-based frameworks, or kind of component-based frameworks. Right? So along with that, I'm not going to flip back to that slide again because we're at the end here, this specific diagram. We also have something, the other kind of single-page front-end architecture that we have is called model back views. Model back views are something like Backbone. They're data-centric. You bind a model into some kind of view, and from that view, it figures out how to render it onto a page, right? Or it's encapsulated in a view object and renders onto the page. And similar to that, right, and this is what a model back looks like. You have a to-do item, you bind the model into the to-do view, and in the to-do view itself, it figures out how to render it, okay? And markup-driven is slightly different. What you do is you write markup in a template using some kind of template engine, and then you can access the model directly using variables. And an example of this is something like this. You guys some of you probably recognize this. I think this is Mustache or Handlebars. Which template engine, or which template are we using here? I don't remember. It's either Handlebars or Mustache. Essentially, it's a template-based engine, and what we're doing is we're doing markup-driven type of client-side development. All right, so let's talk about the model layer for a few minutes. So when we look at this diagram, this is essentially what every JavaScript framework implements in some way or the other. Again, there'll be a slight variation depending on which framework you're using, but almost all of them have the elements that are on this slide in one way or the other. There is a concept of, I'll go to this one. There's a concept of a data store, right? This is something that we have locally, and this is not working. Yes, it is. We have something called the data store, and that can be local storage or something like that that keeps data in the web browser rather than on the server. The data source reads from that and flushes to a backend, usually via Ajax call. And then when we need to have stuff pulled in from the backend, the data source queries it, it stores it in the local cache, it creates model objects, which then get added to a collection. Virtually every front-end framework uses this model, basically this kind of architecture, something similar to it. Right? If you're using a front-end if you're using a front-end framework that supports models, they all do this. They all have this semblance of a cache where it can store data locally, so it doesn't have to keep going back and forth to the server, and it allows you to do things like batch updates to the server instead of having to always send every update to the server to be persisted. It gives you more control over how things work. Right? So again, the data source allows you to retrieve models by search or ID. The model is basically a data container. It also emits changes when models change, when model objects change for one reason or the other. And we also have a collection object which contains models. It allows you to do things like ordering and other things like that. And again, the idea is that when something is added or removed from a collection, those collection objects will emit events so that you can catch them and do the appropriate thing. For example, flush those changes to a data store or a database in the back end. All right? So when we talk about the back end can be virtually anything. Right? It doesn't matter what you code it in. And when we talk about single-page applications, we don't really care what the back end is. We just care about what we're doing on the front and how we interface with it. Typically, a back end, in modern applications, a back end is typically REST. We typically use JSON, and you can use XML if you want to. And if you really have to, you can even use SOAP. Right? Is anyone still using SOAP today, by the way? A few unlucky people? Wow, okay. That kind of sucks. So this slide is for you, by the way. I remember I did one project with SOAP a long time ago, and that was the last time I ever used SOAP. So, all right. So the point with making a joke about SOAP is that the trend, hopefully you're starting to see a theme emerge, right? The trend is towards lighter weight solutions, not big heavyweight solutions like SOAP or XML. Use small package data, things which are lightweight like JSON, and we basically want to slim things down as much as possible because we're working in a different way. The common question here is when do we discuss the controller? We talked about the view, we talked about the model. In a client-side framework or client-side model, SPA/SOFEA, we generally tend to think of a controller as just something that glues the model and the view together, right? It doesn't, single-page application frameworks don't have a notion of a big, heavy controller, right? Essentially, the thing that does orchestration between the model and the view is much lighter. So we have a couple of different things that we want to do in the controller, right? Or what we like to think of the controller, but it's not the same thing as what we have in a traditional server-side application. So what does a SPA controller do? And again, I use the word controller very, in a way that is supposed to allow you to think about lighter weight solutions here, right? So the SPA controller is something that renders templates. It allows you to sync the view with the model, right? Or something that you denote as a model. And it's also something that can receive DOM events so that you can make changes in the UI or with the data. Okay? Those are the three typical things that a SPA controller should do, right? Not much more than that. And remember, we still have logic. The logic is sometimes spread in the view, sometimes in the model, but not really in the controller, right? And this is why when we talk about the different types of front-end architectures, we have MVVM, which is model view, view model, and we have MVP, which is model view presenter, right? We don't have MVC per se because it's a different animal. We're not running this code on the server. We're running this code up here in the browser. And that's where we really have to shift our thinking. And the other thing is we are running in a JavaScript environment, which is single-threaded, it's asynchronous, and it's also very heavily event-driven, right? When we typically think of server-side applications, what we think about is something that is kind of, we kind of have loose coupling, but the model view and the controller in reality are very tightly coupled, because if you're working in the controller, you may get a model object like a person, and you make a direct invocation, and you may do person.getName, right? But when we do something like that, we're tightly coupling a model and a controller together, whereas in a single-page application written in JavaScript, we're more reliant on events. So yes, we still need to go get that person object's name, but when we change it, we broadcast an event, and something over here listens for a model object being changed, and then it goes and updates the view. So there's this kind of loose coupling everywhere in the system, right? And loose coupling is generally good. All right, so here's a quick diagram on a visual to help you understand where we have been and where we're going. In a traditional app, again, we have our server. Our business logic is in the server. We generate HTML, and that gets pumped to the client, and basically that's just, client just renders the HTML. That's it, okay? But in newer single-page applications, what we do is we move the UI business logic up into the client, and we generate the HTML in the client, right? We do either direct DOM manipulation, or we create HTML and insert that into the DOM, right? So at this point, a lot of people have a question of, well, this doesn't sound right, right? And so I had business logic. I had business logic here in the server, and I moved it down here, right? Is there going to be business logic in the server in the SPA sense? In the SPA case, yes, of course. So you still have business logic when you're building a single-page app on the server. But the kind of business logic you have is stuff that you may do in the database. So you may have some business logic where you go create a database and grab to grab a bunch of data. That stuff is still there. But other things like algorithms will still be in the database, right? So for example, with what we do, we have RESTful endpoints to go get stuff, but we still have quite a bit of business logic on the server. I'll give you an example of that. So as somebody's using our application, we collect metrics on how well the user is learning a foreign language, okay? And those metrics eventually get flushed all the way down to the database on the server. And then as you're going through tutorial, we'll say, okay, the client will say, okay, server, I need the next set of phrases that the user is supposed to learn based on the metrics that we've collected over time. So it doesn't make sense for me to ship this 10,000, 100,000 phrase database all the way up to the client, right? Because that will obviously crash it, sending this huge amount of data and doing all that processing on the client. So what we do is we still have our algorithms, some of which have patents on them, for selecting what the next group of phrases the user should learn is. That still lives on the server, even though we're building a single-page application. Okay? So hopefully I've given you an example, a concrete example of the delineation between what kind of logic needs to remain on the server and what you push up to the browser. A general rule of thumb is anything that requires a large amount of data or close access to the database is something that you still want to keep on the server, right? It's something that is not specifically user interface business logic. Right? So let's talk about frameworks for a few minutes and get into some of these. It's a lot of people will say, why should we use a framework at all, right? You said that we want to use lightweight solutions. Again, I talked about this a bit. You still need to have frameworks. Otherwise, what happens is you end up writing your own framework. And I have actually given this session before where people are like, yeah, you know what? We just built our own framework, right? And there's some people crazy enough in this world that say, I want to build my own web application framework, right? How many people in this room want to build their own web application framework? Anybody? All right, so there's at least one crazy person in here, okay? But I totally respect that in some ways, right? It's a lot of fun building a framework because you get to really get into the internals and, it's cool work, right? But at the end of the day, building your own framework can be something that can be problematic because once the gentleman in the back who says he wants to build his own framework leaves his company and his friends are still there, he will no longer have friends at that company, right? So that's the problem. At least if you use an off-the-shelf framework like Angular or Backbone or whatever, at least there are thousands of other users around the world that you can go to and either hire or get help from, right? So, and the point of this slide is to make a small joke about, using a framework is not something that is a silver bullet. Using a framework means that you have something else to learn. You have to follow their idioms. You have to follow the way that they want you to write code, the style that they want you to write code in. And that's something that you have to accommodate for. It's not like you're going to build a framework and everything is going to be great. So actually, there are a couple of things I want to talk about before we get to the next set of slides here. I want to go back quickly to talking about some of the issues with building single-page applications. And of course, I won't be able to find it now. But I mentioned a few minutes ago that doing single-page applications is not for everybody, right? There are drawbacks. So I just want to talk a little bit more about this. So I talked about SEO, how it can be slower. You have lock-in framework. One thing that some people do, and I talked about this in one of my sessions yesterday, is that instead of jumping completely into using a front-end framework for everything, right, doing a big bang and building everything, what some people have started to do, or what some people do is they just take out small parts of their application and use a framework with that. And obviously that can be a little tricky, but there are certain parts of your website or web application that you can make a single-page app, and then the rest of it can still be the old stuff, right? So that's one approach that some people take that works relatively well. And the other thing that folks have been doing is when you're looking at building a single-page application, you may want to start a little on the small side and not try to make a very complex user interface, right? But in terms of the drawbacks, you have to watch out for the fact that building stuff can be slower. You do have to have a new set of tools and skill sets to be able to build single-page applications. You have to learn how to use minification tools that can take up all the different things that you have in Angular and put them together, right? Running continuous integration against something that is a single-page application is a different animal altogether than a kind of traditional web application. So you have to learn all this tooling and the process around it, around building a single-page application. You have to make sure you factor that into your overall development cycle. Okay? All right. So a couple of things I want to close on is if you have not seen this website, how many folks have seen the To-Do MVC website? Right, so a few people. This is an excellent website. I'm going to pull it up really quickly. Right, and let's restructure this. But basically what this is if you're building single-page applications and you want to see how these frameworks all implement or have reference implementations for their app, this is a great place to go. I'll tell you why. Because we can go into this website, and for example, I'll pick the Backbone one, just move it into a tab. Right, so it's just a simple to-do web application, to-do list web app, and you can see that every time I make a change here, the page is never reloaded. This is all happening in the browser without ever round-tripping to the server. Okay, and you can see it's a pretty basic application, but it's not something that's super trivial. So what they've done is they've implemented the same to-do MVC application in a bunch of different frameworks. So I open up Angular, and I think someone said they were using Ember. Right, so let's open these up in a couple of different ones. Right, but you can see as I demo this, they're all exactly the same. Okay, so this is an excellent website for going to learn how folks put together the same application in these different frameworks. So if you're at the point where you're not sure what framework you should use, or you don't like the framework you're currently using and you're not too far in your project, you can go to this website and you can look at the implementation of the same to-do MVC application in all these different frameworks. So if we go into our code here, let me go find it real quick, right? So this is the to-do MVC. You can basically go to GitHub, you can pull the entire repository down, and then you can drill into one of these. Actually, let's go and have a look. I think I have this in here somewhere already. Right? So you can actually go in, and you can see that, for example, for Backbone application, this is what it looks like. So let me go back and just open this folder. Zoom out. I just want to drag this into here and open it up. Obviously, this things together, and they have a ton of the different frameworks up here. So I think somebody mentioned Dojo. There's an implementation of, I thought it was up here, if I spell it right. Yep. So there it is. There's Dojo. Someone mentioned Knockout. I know I've seen Knockout on the list. There's also Knockback.js. I haven't heard of that one. Kendo Ui. Kendo is actually one of my favorites. They just open source the core Kendo Ui code base. And then they also have the compile to JavaScript type of thing. So you can look at the same implementation in GWT if you want, or in Dart or TypeScript, right? And then someone mentioned Require.js. They also have an example, for example, of Backbone and Require.js in here. And then probably the most interesting part of this is you can actually go, and someone mentioned Jquery as a framework, but you can see here they have the same to-do MVC application implemented in just Jquery. So if you're just using Jquery, you can actually go in and look at how they would implement that application in Jquery and kind of get a feel for the app. You can see obviously there's a lot more JavaScript here because Jquery doesn't have models. They use other things to build it out. But hopefully you get the idea. And a couple of quick things in closing. You don't necessarily have to use a framework. I already joked about this earlier, but this is an excellent book. It's called Single Page Web Applications. It's by Michael Mikowski and Josh Powell. And what they actually do in this book is they basically build up a small framework of their own from scratch. So I'm not saying you should go buy this book and build your own framework, but it's actually quite instructive to go through and understand all the kind of design and architectural decisions they made as they built up this framework for building single-page applications. So it's an excellent book. It's well worth the read. Okay? And with that, I think we have a couple of minutes for questions. What are the use cases for single-page applications? Okay, that's an excellent question. So typically, single-page apps are good for things that require complex user interfaces. Okay, that's what people typically want. So you know, something that jumps off the top of my mind for something like that would be a shopping cart application. Okay, so you know, you have a bunch of items, you have a live cart, you have like Amazon basically. You have other people like these products, and you know how you have low pain, or other people bought these products while looking at these products. So if you think of Amazon, they have a ton of stuff going on their page. But the problem with that, again, is that you have to be careful if you care about SEO. You have to make sure it works properly and that you don't make it too heavy, right? So that's a good example of something that could benefit from that, from using a single-page architecture. And one of the reasons why we're so interested in single-page architectures and applications right now is we don't have to go back and forth to the server a lot, right? We basically just make small calls for data. So you enhance the user experience and give them something that seems much faster because you don't have to round trip and reload a whole page every time. Okay, so the question was what about the security issue about exposing business logic to the user, right?
We keep the algorithm proprietary, right? We keep it within the server.
Yeah.
This is not the case.
Right. So, but if you remember, so the question was I'm worried about security, about exposing my business logic to everybody, right? So if you remember, I made a very fine point that, like, for example, what we do in our application is when we need to go get the next set of phrase data, we have a patented algorithm that goes and returns the next phrases, but that runs on the server. So we just go to the server and say, this user needs the next set of phrases, and the server runs the algorithm against the database and sends just the next 10 phrases up. So that data is not something that we have on the client. And the other kind of the other nuance I made with that is the business logic that we have in the web page is UI business logic. It's not so much kind of business logic that's core to the database or close to the database. The stuff that's close to the data is typically on the server. We don't move all the logic up. We just move the user interface business logic up.
No, in the case where, based on a particular user role, you need to display certain things. What if you are sending certain information saying that it's read, edit or something from the server end, and then you are displaying it?
Okay,
so,
okay, I understand your question. So what if you have to do authorization across roles, right? So, but you're going to handle that anyways in a certain way, because when the user logs in to the server, right, there's going to be an authentication phase and then an authorization phase. During the authentication phase, when the single page app says this user wants to log in, that role is set on the server already. So when you make a call to the server, you probably have some logic on the server already that, hey, the user wants to go get a list of all the people in the organization. Are they allowed to get everybody's, all the people in the organization and all their salaries? I don't know, something like that. So that is enforced on the server still. So you don't necessarily pump all bits of data up to the client, just the data that you need, and you still have the authorization bit there, right? That will always have to live on the server because you typically want to layer your authorization for access to data on top of the database, not all the way up in the view layer, right? So again, that's actually a very good point in terms of the architecture. That's where it would live. It would live down there. So. Okay.
But then when something is more, where you are concerned about security, maybe this may not be a good choice. Where it's more of a public website or an internet-based thing,
yeah.
I think it's more suitable. If you have more of role-based access to this thing, somehow you might creep out that information to the client.
Yeah,
that might happen.
Yeah, I understand your point, but again, if you're really concerned about the data that you're leaking out or that you're exposing to the outside world, the user will have to log in. So you have an authenticated user, and that authenticated user will have authorization roles that are enforced on the server, right? So that data will never make it out to that data that the user shouldn't see will never make it out in any case up to the client, because even if you have a server-side framework like you're using Grails or Rails or Spring MVC, you're doing that same authorization check when you grab that data and insert it into a template. You're still going to do that same authorization check when you take the data out of the database and send up a JSON block of data. Okay?
Yeah.
So.
Thanks.
Yep. Yes, sir. Yeah. I'm not sure what you mean by only the view will show.
Yeah, so what you talk about the models, right, where you have the contains and then you have a view where you store that data and then you go for backend, okay?
Yeah.
And meanwhile the user read at that, right?
Okay.
So whatever view on the client side we have, so only the data will pop up on the view side. What view we design backend, now we are going to populate in this client side in the single page application, what I understand.
Yes, that's
the first
right.
point.
Yeah.
So what my concern, concurrent modification happens in the for particular data
Right.
on the client side for particular field, let's suppose any field.
Yeah, yeah.
So in that again we are going to make a Ajax call to the server and then checking that, okay, no, I have to go the first, and we have to tackle those things in the server side still again, right?
Okay, so the question is we have two users looking at the same data from the server, and they both make changes to the same bit of data, right? How do you rectify that? Well, you building a single-page application doesn't offer you anything different than another application. You still have, at core, a concurrency problem. So a single page app doesn't solve that problem. You still have the same problem at a fundamental level. You still have to figure out how to rectify those changes. It's no different than building a traditional server-side app. Right? If you had a traditional server-side application, two people click a submit button, they do a post to the server with the updated data, you still have to rectify that on the server. It's no different than a single-page application. You still have the same problem is what I'm saying.
Okay.
Okay?
So the next question, so why we should use this single page? Just to populate the data on the client side, and there is many use cases are available and framework are available in the market where we can use that. The first thing, that means what I'm trying to understand. So we have to use only for for a simple design.
Okay. Yeah, I'm not quite following your question.
So what my concern, so why we should use this single page application? Why? This architecture, why we have to use? Just we have a lot of framework on the market, and then they easily can define and easily can, define your GUI and all the things.
Oh, okay. So I think the question is what are some of the reasons why we want to use single page applications? Most of those answers have to do around interactivity, performance, and usability of the application. Okay, and again, we're kind of going back to the client-server world when we had fat clients, or thick clients is what they're called, and we have stuff on the server, but instead of a thin client and doing more work on the server, we have a fat client and we do more work in the UI itself. So that allows us to have a better user experience and to have faster perceived performance to the user. That's why these things are popular. Because when you click something on a traditional app, it has to make a post, it goes to the server has to generate HTML, send it back, and then render everything, render the whole page again. And that's slow. Whereas if you just make like having a search box, for example, in Google, when you start typing in Google for a search, it starts filling in the search results immediately. In the past, you would enter a search query, hit search, go to the server, come back, and do full refresh, which is much slower. So it's the perceived performance that you get from it that makes that's essentially one of the big reasons why folks like to build single-page applications. The interaction is much better, and the performance to the user is much better as well. It's a much nicer application. Okay? So,
thank you.
Yeah. Go ahead. Okay, so the comment is there are there any tips for increasing the local storage on the client?
From the caching perspective, right?
Yeah,
so
yeah.
If I look at the browser caching capabilities.
Yeah, I think local storage is limited to 5 megabytes.
Yeah, that's correct.
I don't think there's a way that you can increase that without essentially doing something on the person's browser itself. But that actually begs a better question, which is, why would you need to store more than 5 megabytes on the user's thing? I can understand there would be cases, but it's
typically data grids where you have a lot of data which is coming onto a single grid, wherein you're doing front-end processing which is happening, and that's entire business logic is sitting on the front end.
Yeah,
that's where I'm using SPA.
Yeah,
so how do you actually manage that kind of volumes of data on the front end?
You can't increase that necessarily out of the box, right? And there are good reasons for that. But I think, it used to be for when we had Web SQL in the HTML5 standard, where you could have a SQL database embedded in the browser, you could ask the user if they would allow you as the developer or the website person to have a larger database, but the Web SQL standard has been deprecated for IndexedDB. So you may want to look at IndexedDB. I don't know if that allows you to ask the user, hey, this website wants to create a 100 megabyte IndexedDB. I don't know if that exists or not. So, okay?
Thanks.
Yeah.
Hi, my name is Rajan here.
Oh, right there.
Okay, so my question is that what are the use cases that are very specific for Angular kind of a framework versus the use case which are very specific to Backbone? So if I have to choose between two, what are my decision points?
Yeah, unfortunately, so the question was, as you heard, what are the use cases for Angular versus Backbone or whatever? I don't have a good answer for that. The frameworks vary quite a bit, and so Angular, depending on who you ask, Angular is better for things which are more like normal websites as opposed to widget-based websites, right? And so if you're using Kendo or Sencha, that's more like for creating a dashboard. And Angular is better suited for something like creating an Amazon, okay? But again, I don't have a really good answer for that. I think there are a few people who compare these different frameworks, and they may have some hints in there, but unfortunately, I don't think we've really settled on what's a good way to, you have this business problem, which one of these frameworks should you use? I don't think we have, as a community, have something, a good handle on that right now, okay?
These days, everything you develop has to cater to a huge array of viewports, right?
Has to be what?
Has to cater to a huge array of viewports. So
okay.
Mobile devices, tablets, TVs, everything.
Right.
Does using single page kind of architecture, does it have an impact on the complexity of maintaining that kind of multi-viewport?
It actually, so the question is if we have different size viewports, if we're targeting desktop, mobile, and tablet, for example, it actually, building a single page app, in my opinion, building a single page app for multiple viewports is actually easier than building a server-side app because you have the flexibility right in the UI to be able to look at the size of a viewport and adjust the page on the UI itself. You don't have to go round trip to the server and say, I need this other stuff here to show properly on a tablet. You can just make the adjustment immediately in the web browser. You say, oh, I see that the size of the viewport is 1024 by 768, which is an iPad, versus like a desktop monitor, 2560 by whatever 1880, versus an iPhone, right? So you can make those adjustments right there on the in the app itself. So I think it's actually easier to do that. Okay, that's my opinion. I'm sure some people may differ on that.
So it makes sense if you are going adaptive, but if you want to go responsive instead, you think
go responsive, yeah. So I don't know. That's a little bit of a fine line versus adaptive versus responsive. Obviously, I'm talking about adapting rather than being responsive. But the other interesting thing is that if you're using some of these frameworks, allow you to use something like Foundation, which is responsive by default. So you can use something like Foundation with these frameworks. So it's not necessarily limited to that. Okay? All right. I think we're out of time. So thank you for coming. Hope you enjoyed the session.